Welcome to the Journey Shake Cam. Well, today's warm-up is a little review from the assignment you had last night, so let's see how well you can do that. Please do the best you can, and I'll see you in a moment. Number 1 is asking for the weight percent of aluminum sulfate. And therefore, when I write 2.1 molal, the very first thing I need to write here is that this equals 2.1 moles of the solute divided by 1 kilogram of solvent. Therefore, this value has given me everything I need to know in order to solve this problem. Well, my solute is the aluminum sulfate. And therefore, I'm going to take my 2.1 moles of aluminum sulfate, and I hope you got that formula correct. I would expect you did. And change it to grams. And 1 mole of aluminum sulfate has a total AMU of 342.3 grams of aluminum sulfate. And that is from the sum of the AMUs. There are 2 aluminums, and each aluminum is 27.0. There are 3 sulfurs, and each sulfur has an AMU of 32.1. And there are 12 oxygens, 12 times 16.0. And then, as you know, I write them again after I do the multiplication. And I'm going to write these up here. Aluminum is equal to 54.0. The 3 sulfurs are 96.3. And the 12 oxygens, I'm just going to write oxygen, comes to 192.0. And when I add that all up, I get the 342.3 grams of the aluminum sulfate is equal to 1 mole. And when I do the math here, my moles to grams, I come out with 718.83 exactly grams of the aluminum sulfate. Now, by definition, we know that we also have 1 kilogram of solvent, and therefore I'm going to add 1,000 grams. Not 10,000, 1,000. And then I get a total of 1,718.83 total. And then to do the mass percent, I take the mass of my component, 718.83, divided by the total mass, 1718.83 times 100. The mass of the component divided by the total mass times 100. And this is a very large percentage. It is 41.8% because we take percents to the tens place. That's a very large percentage. Because there's only 2 things in this solution, by subtracting this from 100, I could get the percent of the solvent. But the question wasn't asking for that. And that's how you do a weight percent problem if you are given molality. Now, when you have a quiz, I will ask you 1 question, but I will have several questions to answer about that question. And therefore, it is very important that when you are doing a calculation, that we take them 4 places past a decimal and we cut it off, we truncate. And when multiple choice tests is what we're going to have for this topic, as well as the quiz, and therefore it is very important that we follow through with 4 places after the decimal in a calculation, and we do not round to significant digits until the very last step. Well, that's number 1, and I'll be back in a moment to discuss number 2. Number 2 is asking how you would prepare a solution of a specific concentration. And how would you prepare? What kind of a question is that? Well, if I'm going to make a solution, I'm going to determine what mass of the crystal that I'm going to need to weigh out to make that solution. Well, I know that I want a 0.045 molar solution. And remember, whenever I'm given these concentration, I'm going to write it again. 0.045 moles is 1 liter of the solution. I want the same concentration, but I want a different volume. And in order to know how to prepare it, I can't weigh moles on the scale. I need to get to grams. But first, I do have to get to moles. And therefore, I'm going to set up a proportion, and I have 650 milliliters of the solution. Well, 650 milliliters, I need to change to liters because I must be consistent with the units given in the problem. Well, 1,000 milliliters is equal to 1 liter, and therefore I have 0.65 liters here. Then I cross multiply, and it's very important to understand, when I cross multiply, I get moles, and that is not my final answer. I can't weigh moles on the scale, so I'm going to have to go another step. Well, first of all, our X value here is equal to 0.02925 moles of the copper 2 sulfate. And then I change my moles to grams. Well, again, I have 0.02925 moles of copper 2 sulfate, and I'm going to change it to grams, and I want to cancel the moles. You'll remember that what we want to cancel must go in the bottom, and what I'm looking for must go in the top. Now, copper has a mass of 63.6 AMU. Sulfur is equal to 32.1, and we have 4 oxygens, which is 4 times 16.0. Remember, we make mistakes at this little step here. I know it seems very simple, but I like to work it out because I know from experience that that's where we make mistakes. And 64.0. Then I add up those numbers and I get an AMU of 159.7 grams per mole, which is our molecular weight or our formula weight. 159.7 grams of copper 2 sulfate is equal to 1 mole. Then when I do the math, I come up with 4.6712. Remember, I go 4 places past the decimal and cut it off. Then I look back to my original problem. And the number with the least number of significant digits would be 2. And therefore, the 7 will round the 6 up. And my final answer will be 4.7 grams of copper 2 sulfate will be added to a total volume of 650 milliliters. So if I'm asked to prepare a solution, I need to know how much I'm going to, what mass of the compound I need to weigh out on the scale. And that's how you do that problem. Well, today we're going to learn mole fraction and number of ions. So I'll be right back to talk about that. We are going to learn the last 2 types of problems that we'll have in this topic. And then we'll just practice. You know, we always practice so that we get better and better and we'll be ready for the assessment. And the first thing we're talking about is mole fraction. Well, mole fraction is just like any other fraction. It's a piece of the whole, and therefore the fraction should add up to 1. Now, what I want to do is take a look at the worksheet Topic 14, Worksheet B, and the sample problems. In the very first sample problem, we are given 27.5 grams of ammonia and 22.3 grams of sodium chloride and 200 milliliters, and when we're talking about water, 1 milliliter equals 1 gram, therefore I have 200 grams of water. Now for mole fraction, I get everything into moles, add up the total, and then divide by the total. Divide each number of moles by the total number of moles. And therefore here, grams to moles. 1 mole of ammonia is 17.0 grams. Nitrogen is 14, and 3 times 1 is 3, giving me a total of 17.0 grams of ammonia. And then, so that is 1.6176 moles of ammonia. And then I change my grams of sodium chloride to moles. And 1 mole has a mass of 58.5 grams. Sodium is 23.0 and chlorine is 35.5. And this gives me 0.3811 moles of sodium chloride. Water is the largest part here, and we know that 1 mole of water has a mass of 18.0 grams of water. And therefore, when I add this up, I get 11.1111 moles of water. And when I add up all 3 of these moles, I get a total of 13.1098 total moles. And therefore, to get the mole fraction of each, I take my component and divide by the total and get a fraction. Therefore, I'm going to divide each one by the total. And my numbers don't come out very, very simply, but I get approximately 1, 2, 3, and my abbreviation for mole fraction is MF of ammonia. And here I get 0.0291 mole fraction of sodium chloride, and by and large the most part is 0.848 mole fraction of the water. Now it should really add up to 1, and on the quizzes and the assessments we will be given mole fraction to the hundredths place, and it will be very straightforward that way. And that's how you do mole fraction. The next type of problem are number of ions, the concentration of the number of ions. Well, let's look again at the sample problem. We are given a mass of calcium phosphate. And when I'm talking concentration, we need either molarity or molality. And the information in this problem is enough to get molarity. I am given 31 grams of the calcium phosphate. And I'm going to change my grams to moles because I want to get molarity. And molarity is moles per liter of solution. Well, 1 mole of calcium phosphate has a mass of 310.3 grams when I add up the AMUs correctly. You have to be careful with that. Well, this gives me 0.09990 moles of the calcium phosphate. And I'm going to divide it by the volume of the solution in liters. And in this case, I was given 350 milliliters. Well, 350 milliliters, I have to change that to liters. And some of us could just do that in our head and have 0.35 liters. And when we do the math here, we get 0.2854. I look back to my original problem and I need 2 significant digits. And therefore that is 0.29 molar of the calcium phosphate. That is just the concentration of the original salt. And then I have to understand, very, very important, that when I put this calcium phosphate into solution, I'm just going to erase all this, because what we need is the answer here. When I have calcium phosphate and I put it into solution it is going to dissociate. We know that it's a strong electrolyte. It will dissociate 100% to calcium ions and to phosphate ions. Well, if I originally have a 0.29 molar solution of the calcium phosphate, I know that the ratio is that there are 3 moles of calcium ions to every 1 mole of calcium phosphate. And therefore, I get 3 times as much, which would be 0.87 molar calcium ions. It's very important to read the questions in these types of problems because it's a different amount for just calcium phosphate concentration versus calcium ions. And again, I can figure out the number of phosphate ions. I have 0.29 molar of the calcium phosphate. And there are 2 moles of phosphate ions for every 1 mole of calcium phosphate. And therefore, I have 0.58 molar of the phosphate ions. Very, very important point. When this dissociates, then the number of ions that I'm going to get are proportional to the original number. And that's how we determine the number of particles. And that will become very, very important in the next topic. And we're not going to spend a lot of time in the next topic because we're spending the time now learning both mole fraction and number of ions. Well, I hope that helped, and you should be able to do the assignment tonight, and I can't wait to see you tomorrow. Bye!